Hello guys, in this video we are going to learn about the implementation of linked list, and the majority of this video is only focusing on the implementation and not on the theory. And this video is also assuming that you are also having a good or a basic knowledge about the linked list. Okay, for a quick recap, I'm going to explain and I'm just going to revision for you. So a linked list is a data structure. It's a linear data structure in which the elements are stored at random locations. We can call this data as these elements as a nodes, and a node is which is containing a data part or link part in a linked list. And these elements in a linked list are linked using the pointers. Okay, we're going to use this head pointer as the first reference, and the end pointer as recognizing the last reference, and the temp pointer for taking the copies of this and allocating the memory again and again. Okay, you're going to understand this very clearly when we're implementing it. Okay, and I'm also going to mention time complexities of this. So let's see that. Wait a minute. You can see the time complexity here. For accessing any linked list, we are going to traverse the linked list up to n. Means we don't know how many elements are there, so we're going to traverse. For traversing any linked list or any data structure, I think we're all required this n times. For accessing it, we are going to require order of n, and searching also we require order of n because there is no hashing here. For insertion, we are going to have order of 1 because we don't need to access anything. We just need to add that the ending. For that, we just need order of 1. For accessing and inserting at some other positions, like for example, if you want to insert at the middle, then we're going to iterate from considerable iterations. Deletion also one is the worst cases. I just want to remember this because this may be useful for your iterative purpose. Okay, now let's go to the implementation part. First, we're going to import the nested libraries. We're going to use stdlib because we are using malloc function to allocate memory for the nodes. So first we have to define on custom data type. In C language, we all know that for defining a custom data type, use structures. And this structure, what we need a link part and a data part. So for that, we're going to define two. You may get a doubt why I define a struct node pointer instead of defining end pointer, because we are not pointing a variable which is only able to store in data. In data, we are going to point a variable which is capable of storing the link and the data. So we already know that for pointing any data type, the pointer must be also in the same data type. So for pointing any node, we must need the pointer which is able to point the node. For that, we're going to define the structure node pointer. Now, I think you are all understood this, and we're going to use majorly 3 pointers. For that, I'm going to define them globally because I'm going to do this using functions and end pointer. So let us create a create function. So now we have to check whether the head is null or not. I will explain you why. Because at the beginning, if there is no nodes, means the head is null, right? So we have to check the condition. Why? Because we are treating head separately because we are only able to refer or we are only able to start from the position just by using this head pointer. Otherwise, we don't know where to start. Okay. For the ending, we all know we are having the indicator like null, means the link part of the ending node will be null. For that, with it, we can recognize where is the null node. Where is the last node. But for remembering and for starting position, we must not change the reference of head. So for that, we're specially checking if there is head is null, means the linked list is empty. So if the linked list is empty, we have to allocate the memory first. I mean, first for the head pointer. So whatever memory we allocated, I mean, what this means is in some random location in the memory, this node will be allocated, means this space will be allocated. So we are going to store the value and the link in that space. So for that, in the data part, we have to store data, right? So for that, we have to define a variable for storing, I mean, for buffer. So enter the data. So whatever data the user is entering, we are going to store the data in the node. So for that, we are accessing the node data part and we are storing the data part, the data in the data part. So let's assume means the user is only want to create a one node. So the starting position and the ending position will be same. Okay, let's forget this scenario and assume like you are standing at one position. So how much time you stand there? That is the only, I mean, wherever you start, before walking anything, wherever you start, that is the starting position and that is the ending position for you. If you begin walking to somewhere, only in that case, the starting position and the ending position will be different. Same also happens here. Means the head position and the ending position will be same at the first because we don't know how many nodes are existed, how many nodes are going to happen, and how many nodes are going to delete. So we don't know. For that, we are going to assign this as last node. So what last node contains? Null. Okay. So whatever we allocated, the head pointer must not be changed. So the end pointer must be changed. Okay. Let us take a scenario. Let's assume wherever you start, the, the starting at the beginning, at very first, the starting position and the ending position must be in the same place. But what happens is when you move forward, the end position changes. I mean, what the end position is, wherever you go, the updated position will be the end position, and the starting position must not change. So now what you observed here means that the beginning, at the starting and the ending position are same. But when you are moving further, the end position changes. Same also happens here. Means here also we are assuming that ending and head are same. Means if there is only one node, what to do in that time? Okay. Now it is the another case. For example, user also created the head node and user also wants to create further nodes, means some other nodes. Now we have to link these nodes to the head. So for that, I'm going to use some temporary pointer which I have defined here. So whatever memory we were allocated using temp variable, I mean temp pointer, we are going to store the required data there, which we are willing to take from the user. So I'm going to take data. So whatever data I took from the user, I'm going to store the data in the node which I had assigned just now. Let's assume. So I already told you that we don't know where the last position is. For example, let's take this example. Now we are here. The head pointer is here. The head pointer is here. So now we are allocated. I mean, the user asked us to allocate another node. So for that, we are allocated data. I mean, we are allocated memory location for this. So we don't know whether a user requires this another node or not until user chooses to append the data. So we don't know, right? So in that case, we'll assume like this node will be the end node. I mean, this is the ending node. We don't know where it going to end. I mean, whether he is requiring some other nodes, some 10 nodes or 5 nodes, we don't know. So for that, we don't know. That means we are going to assume this pointer as this pointer import as n. I mean, I'm sorry, null. Okay. Now you have to remember the concept which I mean, the scenario which I had told you before. what I told you, the starting position and the ending position will be same in the beginning. So the head pointer will stuck here. Means the starting position will stuck here. Now end position has to move to here because we are allocated the memory, the newly memory here, and we have to link this, right? So for that, I think you not understood this. So head pointer means at the beginning, the starting and the ending position must be same. So what he happens here is the starting position sticks to head and the ending position moves whenever, how many adds, how many nodes we are going to add, the last updated node will be the end position, right? So here we are added temp node, means now this temp node is the ending position. Now we have to link this temp node. Why we are linking means, let me tell you, because now the head pointer and the ending pointer are in the same position, in the beginning. So now we are newly allocated temp variable here. So we have to link this part to this part at the first, right? So here we reference it is, here the end is referenced by head pointer. Now we are going to link this temp node to this head node, like that. This end of link is equal to temp node. Now what happened here is, now this node is successfully linked to this node. Now we have to change this the ending, because here the starting position and the beginning and ending position is not same, because it was already changed. Means there are two nodes, so there is no chance that starting and the ending position must be same, because there are two nodes, right? Now this is the starting position and this is the ending position. Now whatever data were appended here, we have to update the ending position. For that, we are going to update this ending position and is equal to temp. Now we have successfully created the linked list. Now we have to perform traversal. For that, I'm going to take a function like this. Now here we are going to use the reference of head variable. Head variable. I think now you can understand the importance of the head variable. Not variable, but head reference. What happens if I use head instead of temp? What happens? It just goes away and we lost the reference. So if that is happened, so we don't know where the linked list is, and we know we lost all the nodes. We will lost all the nodes and we'll all the data. We can use it if there is only one time traversal, but here it is not. We're going to traverse as many times as we want. For that, we all need head pointer. The pointer must not be changed. Let me have explained you this traversal. So first, the head is the temporary is referenced by head. We are storing the reference of head in temp. Now, this variable, why there is a null condition here is, the null means the termination of the linked list. Until the termination of the linked list, we are going to print the data and we are going to move the node to next position. We all know that this node is containing the link part of next position, right? So this means now the temp of link means the next position. So the current position is equal to next position. So this will become next position. Like that, next position not equal to null. So next position of data. Now the data will be printed. Now it repeats the same until we reach to null. Okay. Now we implement the implementation on the traversal. Now we are going to implement our main function. So I'm going to run an infinite loop, because we don't know how many times the user want to allocate the data for the linked list. I think it's the main use, right? It is used to allocate memory dynamically, not like array. For that, it's better to always use these loops, because we don't know how many times the user wants to enter the data. Show the data. So if choice is equal to 1, I'm going to call create function. If choice is equal to 2, I'm going to call trav function. Trav means our traversal function. Now we're going to run this. can enter the choice. So first we are going to append elements to our linked list. Wait. We give some new line here. I think we didn't assign data here. I'm sorry. You can see here we have not stored any data. So that will be the error ampersand data. Okay, now it's fine. Now I'm going to display the list. Okay. Okay, let me make you this some clearer. I mean, I want to give some space. So now it will be some good. I mean, for watching the out. Now we're going to display the list. So now you can also append the list, append the elements to the list. I'm going to append 4. Now I'm going to print this. Now I'm going to append 5. I'm going to print this. Okay. Like this, you can get linked list using these 3 pointers. In the next video, we're going to see the reversal of linked list using recursion and using references. Okay. Thank you.